video tutorial, you are going to see how to check a data whether it is normally distributed. So we have to check a data whether it is normally distributed before going into the parametric test. Say I want to perform independent t-test, then I have to check whether the data is normally distributed or not, because if it is normally distributed, we can go to the parametric. Otherwise, we have to select the non-parametric alternative tests. Okay, so in this video tutorial, we are going to see how to perform the Shapiro-Wilk test for normality. This is one of the popular tests to find out whether the given data is normally distributed or not. So if you take the Shapiro-Wilk test for normality, the null hypothesis of this test is normally distributed. So the p-value should be greater than 0.05. The alternative hypothesis is not normally distributed. The p-value obviously should be less than 0.05. So after performing the Shapiro-Wilk test, you have to see the p-value. If the p-value is greater than 0.05, you can conclude that your data is normally distributed. If the data is less than 0.05, then you can conclude that your data is not normally distributed. So based on this, you can select either the parametric or non-parametric tests. Okay, so now let us see how to perform this Shapiro-Wilk test. So the name of the function that we have to use is Shapiro.test. So this is the name of the function. You have to click this. Then inside this, you have to click the data or the variable for which you have to see the the normality. So what we can do is we can import a data set, an example data set to perform the test. Okay, so I'm clicking the import Excel sheet, then browse. I'm going to a folder in which I have saved some example files. Okay, now I can able to see the preview of my data. Yes, this example data contains 3 variables: gender, CRP level, and D-dimer, which is ready to perform the independent t-test. I want to check whether the data is normally distributed. So just I have to click now the bottom, you can see import button. I'm just clicking import. Okay, now the data has been imported. Here in the environment window, you can see the data name, independent t-test with the observation, 20 observations with 3 variables. Okay, now your data is there, and I want to see whether the CRP level, I'm going to compare the CRP level with the gender. I want to see whether the CRP level data are normally distributed to perform the independent t-test, that is a parametric test. So to perform this, I have to first type the name of the data. I have to tell the R, what is the data in which I have to select the variable. So for that, what you have to do, you have to just click the dollar symbol. Now it will show the available variable under this data. I am going to select the CRP level. Okay, now just click run. Yes, now in the console window, you can see the Shapiro-Wilk normality test result. Here you can see the p-value. It is 0.1796. So now we are favoring the null hypothesis. So the null hypothesis is normally distributed. So your data is normally distributed. So this is what you are going to conclude. But apart from this, you are also supposed to see whether there is any outliers, any extreme values in your data. So to do this, we normally prefer the box plot. So let us now also perform this box plot to confirm that our data doesn't contain any outliers, the extreme values. So to perform the box plot, just click BOX. It will show the available function. So I'm selecting the box plot function. Now I'm going to enter the variable. So for that, first I have to select the data, then click the dollar symbol, then select the CRP level, then click run. Yes, now the box plot has come. Here you could not see any outliers. So there is no any extreme values in this data. So your data is now perfect to perform the parametric test. So I can now go to the independent t-test to find out whether there is any variation in the between the gender regarding the CRP level. Thank you.